Okay, so in geometry, you learn a lot about triangles and the relationships between their sides and angles. And some of the stuff we do today, you probably already learned in geometry, but it's been a couple years and you may or may not remember. I know a ton of you are seniors and you're done taking the ACT, but there's a whole lot of juniors in here as well. And there are 4 trigonometry questions on the ACT, and some of them you can get right in like 30 seconds or less because they're super easy because you know how to get tricky with it. All right, so on these questions on the front, you do need to know that this is a red side, and you obviously can't tell on your paper. This is a blue, and this is a green side. All right, so if you were going to order the sides from smallest to largest, what is the smallest side? The red side. All right, and then the next smallest? Green. And then the largest side should be the blue side. What if you were going to order the angles? You'll probably have to look on your sheet. I don't know how well your eyesight is. From smallest to largest. Which one looks like the smallest angle? A, and then B, and then C. So C is going to be the right angle pretty much on all of these problems. And if it's a right triangle, the right angle is the largest angle. All right, and do you see any relationship in these orders? Like where they are on the triangle and the small, medium, and large? Opposite. And hopefully you remember that from geometry. So what you would do in geometry is you would label side A opposite of angle A, and you would call it a lowercase a. Do y'all remember doing that? No? I think you did. I haven't taught geometry in a long time. And then opposite of angle B would be side B, and it would be lowercase. And opposite of angle C would be side C. It would also be lowercase. But the opposite, like the smallest side, is always opposite of the smallest angle. So we're just going to abbreviate that and just say that they are opposites. All right, so we do have red, green, and blue again on these 2 triangles. All right, so in triangle, first, what relationships do you see between these 2 triangles? What do you notice about the angles? Yes, same angles. Now, I saw none of you got a calculator. We don't really need a calculator. Maybe one person did. We don't really need a calculator to do most of the stuff we're doing today, but you might need one to see the relationship between the sides. So if we take this blue and multiply it by something, it will give us this blue. If we take this and multiply it by the same thing, it'll give us this. Good job, a new writer and figure it out. All right, so it's going to be 2.5 times the sides in triangle 1 equals the sides in triangle 2. And that is going to make these triangles similar triangles. And that's something you may or may not remember from geometry. Plus. Sure. All right, so let's say we wanted to find this red side on triangle 2. What would we do? No, we don't have to. We can do something quicker. Yeah, take 3, multiply it by 2.5, and that's 7.5. So let's label it 7.5, please. Okay, so I want you guys to do this table and just do the fractions. Unless you want to use a calculator, I can give you the decimal answers. So what I want you to do in this row for triangle 1, just take the green and divide it by the blue and just leave it as a fraction. And then take the red and divide it by the blue and so on. And then do this row, just do all that same stuff with triangle 2. So just set up those fractions for me real quick, please. Glad you're paying attention though, that's great. All right, so when you're done with your fractions, just go ahead and fill in those decimals for me, please. What do you notice? How about the decimals?
The fractions of each side are the same.
Yeah, you get the same because they're similar triangles. So the ratios are the same because the sides are proportional. Now, when you guys are doing those fractions, you are actually finding trig ratios. So when you did the green divided by the blue, do you know what you were finding in relationship to angle B? When you did green divided by blue, you were finding the sine of angle B. So sine looks like sin, but it's not. It's just sine. What about when you did red divided by blue? Anybody know? Yes, that's the cosine of angle B. And then green divided by red, the tangent of angle B. Okay. All right, we are going to skip question 6. It'll be fine. And I'm going to show you guys a video from 13 years ago. So it's kind of cheesy, but it's a good video for remembering sine, cosine, and tangent. No, did it sound like me? is my favorite part. So there's that one. All right, let's do it.
All right, twin. I'm definitely putting that one on the playlist.
It's on Classroom if you need to find it again and watch it.
I won't.
Put it on your playlist. Aw, I thought it was cute. All right, so what's the acronym to remember? SOCA-TOA.
Let's do some old hippie. Oh, another hippie. Tripping on acid.
Yes, there's that also.
Some of these.
Is that what you learned?
Yeah.
Where?
This teacher right over there, or no, my teacher back at school.
Most say. I don't think most teachers teach that here, but it's fine. I learned Oscar had a heap of apples.
What?
I just remember that sine, cosine, tangent, and it was Oscar had a heap of apples. So ever since I've been here, we've done SOCA-TOA at this school. So if you learn something else, it's fine. Use whatever. You just need to know like which side is opposite, hypotenuse, and adjacent. Theta can be either one of these two angles. I'm just putting it in the bottom left. It doesn't matter where it is. It can't. Theta is not going to be the right angle. It's going to be one of the other two acute angles. And the hypotenuse is always opposite of the right angle.
That's always the longest side, right?
It is always the longest side, exactly. The opposite is opposite of the angle. And then the adjacent is going to be the one that side touching. Adjacent means beside or touching, but not the hypotenuse. So. All right, so then when I want to find the sine of an angle, all I have to do is remember the so part is SOCA-TOA, and that the sine is going to be the opposite over the hypotenuse. We can abbreviate it unless you want to write it all out. All right, then if I want to do the cosine, I'm going to remember the co part is SOCA-TOA, which is going to be the adjacent over the hypotenuse. And then tangent, we're going to do the TOA part of SOCA-TOA, which is going to be the opposite over the adjacent. Now, even though I mentioned before about the ACT, and there's 4 trigonometry questions on the ACT for the juniors, but even if you're a senior, you are going to take a math class in college. And so anything that you can learn before you go to college is going to be helpful to you for sure. Okay, so let's do some of these problems. On triangle, or on number 1, in the triangle shown, we're going to find the sine, cosine, and tangent of theta. So theta is this angle right here. So if I'm going to find the sine of that angle, what 2 numbers would I divide? Right. So this is opposite of theta, and then this is the hypotenuse. So the sine of theta is going to be the opposite over the hypotenuse, and that's it. There's almost always a question like that on the ACT where you just have to find the sine of the angle. Just do the fraction. You literally can get right in 5 seconds. All right, and then cosine, we're going to need to do the adjacent side over the hypotenuse.
That's a 6, right?
I think it's a 5. Yeah, 5, 12, 13 is a right triangle. All right, and then we'll do opposite over adjacent, and that's it. It's pretty easy. All right, and then for number 2, we're going to find the missing sides. This is the part of the video. It looked like he was like a PE teacher or a coach or something that was talking. And so you have to decide which trig ratio to use depending on how the triangle is set up. So this is the angle that we know. This is the side that we want. And this is the side that we know. So out of the 3 trig ratios, which one would you use for that angle and those sides? Cosine. So if this is the angle, this is the adjacent. So we would say that the cosine of 47 degrees is equal to the adjacent over the hypotenuse. And you're going to do one of 2 things to find x. You're either going to multiply or you're going to switch. And so what he said is if x is up high, then you're going to multiply. So x is going to be whatever 3 times the cosine of 47 degrees is. Now, today is not a good calculator day, but it's okay. Once we get enough calculators for everyone back, it'll be tomorrow. You just make sure your calculator is in degrees, and then you just type that in just like it looks. You don't have to put the degree symbol. You just type it in with the 47, and you get approximately 2.046. So that would be the length of side x in this situation. Now, I always kind of check myself whenever I'm doing these because I know 3 is the hypotenuse, and like someone said earlier, it has to be the longest side. So if I do this problem and I get that x is like 3.2, I know that's wrong because the hypotenuse has to be the longest side. All right, let's look at this triangle for this one. So this is our angle that we know. This is the side that we want, and this is the side, I said it backwards. This is the side we want. This is the side we have. What trig ratio would you guys sine? So we would say that the sine of 57 degrees is equal to the opposite over the hypotenuse. And then this is the situation where if the variable is down low, you're going to switch, So x goes where the sine of 57 degrees is. And sine of 57 degrees goes where x is. And then you just type that in the calculator just like it looks. And you're going to get approximately 12.878. Now, he also went on to talk about finding the angle. We're not doing that today. I'm sure we'll do that soon, but not today. All right. Then on number 3, this is a multiple choice question. So which one of these triangles could demonstrate that when we took tangent of A, so here's angle A, they're all super tiny. We took the tangent of that angle, we got 5 over 3. So what does that mean the 5 should be? The opposite? And the 3 should be adjacent. Now, none of these are labeled, but there's only one triangle where the opposite side is longer than the adjacent side. Say, did you say D as in dog?
I mean, C.
Okay. D is not true. They're the same. That little bar means they're congruent. So this isn't a particularly good question, I don't think, but I would have put the numbers in. But I appreciate Calcmedic making these help for me. All right. Y'all good? Okay, and then number 4. Explain in words what the statement tangent of 11.31 degrees equals 0.2 means. So what does that mean if you took the tangent of 11.31 and you got 0.2? What did you do to get 0.2? Right, you divided the side opposite of 11.31 degrees by the side adjacent, and got 0.2 or 1/5, however you want to write it. Okay, one more question. So in number 5, we know that, or if the sine of theta is 3/4, find one set of possible values for A, B, C. There's an infinite number of answers for this because of this whole ratio thing. Like if all similar triangles are going to have the same sine, I'm just going to do the easiest one we could do, which is if the sine of theta is 3/4, that means 3 can be the opposite side. What would 4 be? The hypotenuse. Oops. I keep wanting to write hypotenuse with a B. Okay, so here's theta. So I could say B is 3 and C is 4. Does that mean A is 5?
No.
We're good. 3, 4, 5 is a right triangle, but the hypotenuse has to be the longest side. So A is not. It's not 2. 2, 3, 4 is not a right triangle. But we can figure it out. What can you use if you have two sides of a right triangle? You want to find out the Pythagorean theorem. A squared plus B squared equals C squared. So A squared would be 14 minus 9, or 7. So then A is the square root of 7. So it's 3 possible values out of an infinite number of values. All right, what questions do you guys have about trigonometry? Do you love it as much as I do?
It does seem interesting.
It is interesting. It's probably the most useful math that you'll learn in high school.